So let's talk about the limbic system. What is the limbic system? Well, it's a set of structures in the brain, and many of those structures play an important role in regulating emotion. Now, something that gets kind of confusing when you talk about the limbic system is that experts can't actually agree on what structures make up the entire limbic system. So for our purposes, I'm going to address some of the most important structures and ones that everyone pretty much agrees are part of the limbic system. Now, before I get going into the nitty-gritty, so to speak, I want to give you a quick overview of what structures we're going to talk about. And the way I remember these structures is through this little cartoon here. This is a hippopotamus, and he's wearing a hat. Now, why is this hippopotamus wearing the stylish hat? Well, this is my way of remembering the four most important components of the limbic system when it comes to emotion. So we see a hippopotamus here. I'll write hippo. And we see him wearing a hat. I'll write hat. Now, for this to be a mnemonic, it has to be something useful. And the reason I think of this is these are the four main structures of the limbic system when it comes to emotion. So HAT stands for hypothalamus, A for amygdala, T for thalamus, and hippo, short for hippocampus. And these happen to be the four structures that I'd like to talk about. So let's get to a little more complicated diagram. And what you see here is my best attempt at drawing the limbic system. Now, limbic system structures sit on top of the brainstem, and this is the brainstem. And you can imagine this as the very bottom of your brain, and here's the spinal cord coming out of it. And the spinal cord goes all the way down your back to about your tailbone. Now, the limbic system are these structures up here that are drawn in bright colors. Now, to orient you to this diagram, this is what you would see if you pulled off like the top part of your brain, which is called the cortex. And it's facing in this direction. In other words, while this isn't anatomically correct, let's say your eyes are here, your nose is here, and your mouth is here. Again, this is not anatomically correct, but this you can see is the front, and this is the back. So I kind of drew it at an angle so you can kind of get a 3D idea. So let's remove this and go back to talking about the anatomical structures. So this blue thing here, this is called a thalamus. And you actually have two of these, one here and one on the other side. So your thalamus functions as like a sensory relay station, meaning the things that you see, hear, taste, touch, all these senses you have come through your nerves and ultimately end up in your thalamus. And the thalamus directs these senses into the appropriate areas in the cortex, as well as other areas of the brain. And I mention this in terms of an emotion lecture because emotions are very contingent on the things that you see, the things that you touch and hear. Now, you may have noticed there's one sense that I didn't mention, and that's the sense of smell. And the sense of smell actually is the only sense that you have that actually bypasses this thalamus. And instead, it has its own private relay station that when it comes from the nose, it goes to a certain area in the brain. And that area of the brain actually has to be very close to other areas that regulate emotion, which explains why sometimes certain scents can evoke very powerful memories and bring you back to a certain moment in time. But in terms of emotion, I mentioned thalamus because of how the senses play an important role in your emotions. Now you see here there's these two purple structures, and this is known as an amygdala. Amygdala. Now the amygdala is sometimes called the aggression center, and experiments have actually shown that if you stimulate the amygdala, you can produce feelings of anger and violence, as well as fear and anxiety. I'm going to put stimulate and represent it as a dark green plus sign. So if you stimulate the amygdala, it invokes feelings of anger, violence, fear, and anxiety. On the other hand, if you've destroyed your amygdala, and I'll represent destruction as a red negative sign, If you destroy the amygdala, it can cause a very mellowing effect. All right, mellow. And this mellowing effect, in the context of a destroyed amygdala, was actually noted by a psychologist named Dr. Kluver and a neurosurgeon by the name of Dr. Busey. And I mention Kluver and Busey because in medicine there's actually a syndrome known as Kluver-Busey syndrome. And that's when there's a bilateral destruction of your amygdala. And bilateral means both. When you have bilateral destruction of the amygdalas, that can result in certain symptoms that are often seen, like hyperorality, which means you put things in your mouth a lot. Also, hypersexuality, as well as disinhibited behavior. And disinhibited behavior is when you ignore social conventions, you can act very impulsively, you don't consider the risks of your behavior, so you do dangerous, reckless things. So that's Kluver-Busey syndrome, and that's, again, when you destroy both sides of your amygdalas. And the way I remember this is I think if you stimulate the amygdalas, that can cause fear and anxiety. And people who have anxiety disorders or experience an anxiety attack, sometimes they're given a medication known as a benzodiazepine. Sometimes they're called benzos. And these benzodiazepine medications function pharmacologically very similar to alcohol. And think of what happens when people consume too much alcohol. Sometimes you see these types of behaviors. You see hyperorality. You might be eating a lot. You might have hypersexuality. And of course, you get disinhibited behavior. Think of the person with a lampshade on their head. They're ignoring certain social conventions because of the effect of alcohol. So that's how I remember the effect of stimulating versus destroying the amygdala. Now this green structure here that you see curving around the thalamus is known as the hippocampus. And the hippocampus plays a key role in forming new memories. What it does is it helps to convert your short-term memory, abbreviated as STM, it helps convert that short-term memory into your long-term memory. And I mention that in this conversation because when you think back in your memories, whether it's short-term memory or long-term memory, these memories can invoke emotions as well. So the hippocampus is an important structure in forming long-term memories. And people with damage to this area, they have difficulty forming new memories. So everything that they experience just basically fades away. Now, what's interesting about this is if your hippocampus is destroyed, while you can't form new memories, you still have your old memories intact. So your long-term memory functions just fine. So that's the hippocampus. Now lastly, this orange structure here, this orange structure is the hypothalamus. And hypo means below. So hypothalamus is below the thalamus. And here's the thalamus, and it's below it. So that's where it gets its name from. And the hypothalamus is actually a very tiny structure. And this diagram here really exaggerates the size of the hypothalamus. The hypothalamus is so small, it actually makes up less than 1% of the total volume of your brain. It's about the size of a kidney bean. And the hypothalamus plays an incredible role in regulating so many functions in your body. But for our purposes, we're talking about the limbic system structures in terms of emotion. So when it comes to emotion, the hypothalamus you can think of as regulating the autonomic nervous system. I'll abbreviate it as ANS. In the autonomic nervous system, you can think of as fight or flight versus rest and digest. Now, I'm going to discuss this further in a different video, but right now just think of it as regulating the autonomic nervous system. And it does this by controlling the endocrine system, by triggering the release of hormones into your bloodstream. And some of these hormones that are triggered to release are things like epinephrine or norepinephrine. And epinephrine is actually very commonly known as adrenaline. So if you ever think of the phrase like a lot of adrenaline pumping through your veins, that's actually being regulated by the hypothalamus. Your hypothalamus is also involved with regulating other basic drives like hunger, thirst, sleep, sex. But in terms of emotion, I think it's most important to note that it regulates the autonomic nervous system, that fight or flight or rest and digest response. So that's the limbic system. And these are the four basic structures: the thalamus, the amygdala, the hippocampus, and the hypothalamus. So these are the basic structures of the limbic system.